As is the goal with any unit test, our objective here when we want to unit test our MVC application is to verify that our controllers return the correct action types. And then more specifically, when we want to verify what they're returning inside of them, in some cases a view or a redirect, we really want to get into the specifics of what is returned. So what we're going to show in this video is we're going to actually walk through how to write a unit test for an MVC controller. The very first ones we'll use are some examples off of our Fly-by-Night Bank website, where what we will do here is we'll have some actions and tests already written, and we'll walk through and explain what actually each is doing. The compound interest action was created to create a form so that the user could go into our website and enter in information and calculate a compound interest result. What this action does actually is this is the get action, and what it does is it returns a view result with a view name called compound interest. If we were to write a unit test for it, things that we might check is that if we call the compound interest method, do we get back a view called compound interest? The reason that we would do something like this is because it's very easy to create a typo or to change something. And so if I were to change this from compound interested or interest to interested, there would be nothing wrong with my code, but unfortunately that would have an error message when my user comes to my site and tries to calculate compound interest. So what I'm going to do actually is I'm going to go into our unit test and show how this would actually be written to check for it. Our unit tests for MVC look very similar. They have an arrange, act, and assert. But what we're going to do here is in our arrange, we're going to create an instance of a calculator's controller. In our act, we're going to invoke the compound interest action. We're invoking it directly from a unit test, so there's no real request or response that's coming in as if someone were browsing to a web page. And what we're going to do is we're going to expect that the return type is a view result. Normally the MVC framework does that for us, but we have to check ourselves. And so we're going to try and cast it using the as keyword. The way this works is if it can be casted, it will, and it will be saved inside of result. If it cannot, then result will be null. Doing that allows us to write two assert statements. The first one being, let's check to make sure that it did in fact return a view result. So we're going to check is not null on the result object. And then if that passes, the next assert statement we'll do is we're going to check the view name on result, and we're going to see, does it match the same name of the view that I expect this to be? All right. When I run this test, ideally what it will do is it will verify if my controller action is working correctly. So it's compiling our code, and it runs, and it verifies the right view comes back. If someone were to go in and later change this without updating our unit test, they've changed the view name, but our unit test still expects compound interest, and they were to run this test again, what it will do is it will fail as we expect it to be because the expected result does not match the actual result. And that's the idea here for a unit test in a given controller. Other things that we can check for is some of our actions return a model out with the view. So we can actually check to make sure that the model did come back and that the user did not pass some sort of different type than we expect. Because unfortunately, our view method is not strongly typed and it accepts a model of any type, as you can see from the IntelliSense. As long as it's an object, it's okay. So what we'll do here in our unit test for it is we're going to actually create our controller. We will invoke the compound interest result action, and we'll pass in the required arguments, and then we'll proceed to validate each of the different outputs. And so we'll guarantee or check for a view result as the output. We'll check to make sure that the right view name came back out, and then we'll validate, was there something passed in for the place of the model that was not null? Assuming all three of these pass, we can then check if we are interested to see the type of the model, and we can guarantee that the type is a compound interest model. If any of these fail, the entire test will fail. And so that's a good way of checking to make sure that our action returns back the right view and model for the purpose of our test. If we were to go into our action and change it from model to null, or just to get rid of it altogether, when someone runs the test again, the expected result will not match the actual result, and so we'll quickly be notified with an error telling us exactly what statement failed for us. It tells us it failed on line 53, which is our check for null on the model object. If I go back in and I pass in the model and I rerun my test, then hopefully my test will then pass. Perfect. Another type of test that we might write is something that returns a different type of result besides a view. So with our survey controller, we actually had an instance of the post redirect get pattern in which the user would browse to the index action and see the empty form. So we would normally write a unit test to check to make sure this returned back a view result and its name was index. But when they posted the data, they sent in a survey that they were saving. And things that we might want to verify is we want to make sure that this returned back the correct redirect to the survey/confirmation route. And so the way that we would do that is this is a type of redirect to route result, and we would have to, in our test, check the data type and make sure it matches these different parameters. Also, we do have to save our survey to the database. Now, because this is a unit test, we want to make sure that we have a loosely coupled design so that we can actually not have to physically save it to a database, but more or less simulate the saving to a database. So our survey controller uses dependency injection through the constructor. And so when we create the survey controller, we have to pass in something that implements the iSurveyDAL. So let's go look at that unit test. We're going to skip the get and we're just going to show the post, but it's still very similar. We have an arrange, an act, and assert. Now in our arrange, many people will pass in the dependency by creating a class implementing the same interface. Often that's called a test double because the class will actually have no additional value other than just to fill in for that spot. What other developers might do is they'll use a mocking framework. And a mocking framework lets them simulate that object within the context of a given test so that they don't have to go off and create a whole class just for each test. I can actually configure it for this test to work in one way, and then the behavior for a different test can be completely different. So here I'm going to instantiate our mocking object. I'm specifying that it implements or mocks the iSurveyDAL, and then I'm going to pass it into my survey controller using the object property on the mockDAL object. So when I hover over it, it'll actually show me through the IntelliSense this is the iSurveyDAL that you're actually mocking. And then I just need to pass in any survey to really make this work. So because my index action is overloaded, and that means I have one method called index that takes no arguments, returns an action result, and another index method that takes an argument and returns action result. What I'm going to do in my test is I'm going to pass in the survey model so that we know I'm calling the post action. I'll try and cast it to a redirect to route result, and essentially very similar to before, check to see if that was not null, because if it was null, then it could not be casted. The second things I'll check for then are verifying the different outputs of that redirect to route result. So when a redirect to route result is used, there are different arguments that are created inside this route values property. Controller checks to make sure that they were sent to the survey controller again, and action verifies which action on the controller were they actually sent to. My last piece is a benefit of having the mocking framework. What it lets me do is it lets me verify that this index action actually called my save survey method in my mockDAL. It's one thing to pass it in, but it's another thing if someone were to go in to our survey controller and just get rid of this. Our test would still pass, but we want to make sure that the index action actually called save survey on its dependency. And so what we're essentially doing with that verify is internally it's writing an assert, and it's essentially saying if save survey was never called, this will fail. If it was called, then this will pass. And so if I run this test, it's going to check for a number of different things, but it's going to tell me if my HTTP post action worked the exact expected way I wanted it to. If I were to go into my action and remove that save survey and try running my test, what it will tell me then is my verify statement will fail because I never called the actual save survey method on my mock DAL. There we go. It threw an exception because I expected to be able to call save survey and never took place. So there we have it. Most of our unit testing for controllers essentially is checking for the type of action result that's returned. It's checking to make sure the different parameters in those action results are what we expect it to, because as we saw before, we can change the way our controller works and it will still completely compile. And so that kind of creates a logical error because it's something that we didn't anticipate to happen, but it's completely legal syntax.